Math Studies, paper 2 from November 15, question 5. It's about functions and derivatives. The following diagram shows the graph of the function f of x. I have a cubic, a quadratic, a linear, and a constant term, but I don't know the values n, p, q, and r, so the coefficients are variables, are unknown. And they tell me between -5 and 7, and I can see the curve, so I can read some values in here. The first question states whether the function is increasing or decreasing at x equals -3, and give a reason for your answer. So I need to look carefully at the scale. This is a -2, this is a -4, so -3 is here. That's my graph in -3. I can see that it's obviously increasing, but I need to give a reason, isn't it? So I'm gonna look at the tangent at that point, because if you remember, the derivative is telling me if things are positive or negative, if things are increasing or decreasing. So if I draw a tangent where the function is -3, it's more or less this. What happened with this this line? The slope is positive, so that means that the function is increasing at that point. So I could write down that as the derivative in the point -3 is positive, I can say that the function itself, is increasing. What is the derivative at the -3? It's the tangent to the function, and that point x equals 3. X equals -3. It should be a minus here. Less mathematically elegant, but still correct, would be to say, well, I take the value of the function a little bit before -3 and a little bit after -3, and I see that a little bit before is smaller than a little bit after. That is also a reason to see, well, this is increasing. So I could also say, being less elegant, but I could also say, well, the function in -3.1 a little bit before is smaller than a function in -2.9 a little bit after. So I could still see implies, and let's use the same sentence, implies the function is increasing. Next question B, write down the value of r. What's the value of r? If I look here, what's r? Is this last term, is the coefficient of the constant coefficient, the r. Well, if I remember, I know this from my studies of lines. What is the coefficient that is constant? The y-intercept in case of a line. This mx plus c, this is the c, but the same thing if I have a parabola. I have a quadratic and a linear term, but the c is the constant, is the linear, is the y-intercept. So here is the same thing. If I calculate the y-intercept, if I make x equals 0, this goes, this part goes, this part goes, and this is what stays, the r. So looking at the graph, this value, the y-intercept, is gonna be the r. So again, I need to be very careful of the scale. This is a 0, this is a 200, so this is 100. This needs to be half of it, 150. 150 is my r. Next question. The values of p and q are such as f of x and x cubed minus 30, they're giving me the p, x squared minus 240, they're giving me q, plus r. And now they say find the derivative of it. I can look at the formula booklet and I see that when I have a polynomial function, ax to the n, the derivative is, as we say, the a stays and multiplies, the n fall down, and then x to the n minus 1. So I can apply this to the to the equation I have. The only thing is, well, n stays, isn't it? I don't know what's the value, but it stays. The 3 fall down. That makes 3 times n. The x is 3 minus 1, which is a 2. Here we do the same. The 2 fall down. So, and the 30 stays, multiplies the 2. That makes it a 60. x2 minus 1 is 1. The 1 I don't need to put. And here is like having a 1. The 1 fall down. So minus 240. And I could say this is x to 1 minus 1 is a 0, x to the 0 is a 1, so I don't need to put, and that's my answer. Next question D. Write down the coordinates of the local minimum point. That should be easy. I just need to go to the graph. That's my local minimum. I mean, the graph can go lower than that, but here there is a local minimum. What are the coordinates of that? I just need to read. That's make a 4 in x. And here just be careful with the scale. If this is 600 minus 600, this is 100, isn't it? So minus 700, I'm in the middle, 650. That's the answer. Question E, show that the value of n is 10. How can I do that? Remember that we know the derivative function, but depends on n. And I know at a point in which this is a minimum. I need to remember that when I have a minimum or a maximum, what happened with the derivative at that point? The derivative at that point is equals to 0. So I know that when x is equals 4, the derivative here is going to be a 0. That's for me an equation. So I write down again the equation of the derivative, but I'm going to plug the number 4 every time I see an x. So 4 to the square, 4. And make it equals to 0 because it's a minimum. So suddenly this equation is now all numbers. The only thing I have is the variable n that I will isolate. So I just need to do all the multiplications, put the numbers to the other side, and finally divide by 48. And I can see that n is 10 as I needed to show. Next question F, calculate the derivative in -1. Remember that I now know all the variables, so I can put values to all the coefficients for the function, and the same thing for the derivative. When they're asking me what's the value of the derivative of -1, I just need to plug the -1 in my function. So plugging the -1, doing all the calculations, at the end my result is -150. If I find the equation of the tangent to the graph at the point -1, 350, and then give your answer in the following form. Okay, equation of the tangent. I go back to the graph and I can recognize the point -1, 350. This is here, and they're asking me here, you can have a tangent, but tell us what is the equation of this line, which is the tangent. So I go back to the definition. What is the derivative of a function in a specific value of x? By definition, is the slope of the tangent of the function in this specific value. So if I know the value of the derivative in -1, at least I know the slope of that tangent. So I can write the equation of the tangent, y is equals -150x, the slope, but c, I don't know the c. This information I got is about the slope. What is the y-intercept? I don't know. As for any other line, if I want to find the y-intercept of a line, my tangent here? Well, I need to plug at least a point. Do I know any point of this red line, of the tangent line? Well, I actually know this one, the minus 1,350. So I'm going to plug this value in order to calculate the C. So I know one point that is on the tangent and also on the function, by the way. So I'm going to plug the x and the y value in the equation that I know. The only thing is missing here is the c. I will isolate the c. The value of c is 200. So y is minus 150x plus 200. They want the function, the linear function, expressed in a specific form where I have x and y's and all the values in one side equals to 0. So I'm going to just move it to the other side and start with the x. That will make it 150 plus y minus 200. That will be the answer. Next question, write down the gradient of the normal to the graph at x minus 1. So it's the same point, but now they are not interested in the tangent, but in the normal. Well, for the normal, I have that's AC1 because it's just having the 1 over the 1 of the tangent with a minus. So that makes 1 over 150. Yeah, if the slope of the tangent was 150, the slope of the normal is 1 over 150. The graph of the function intersects the x-axis at point P, as shown in the diagram. Use your graphic display calculator to find the x-coordinate of P. So that's a calculator question. Now I have a function that is cubic, so it's a bit complex, but I know all the coefficients, the 10, the minus 30, minus 240, and the 150. I can put this as a function in my calculator. I have a perfect window. I'm gonna look at this, calculate then the 0, and I will calculate specifically this 0, and I will get the value. So doing this, I get the following value. Remember that I just want 3 significant figures, so 6.39 will be the answer. Last question, let's g of x, which is a linear function in the same window. Use your graphic display calculator to find the values of x where the f of x is equals to the g of x. So the cubic being equals to the linear. That's again a typical graphical calculator. I'll withdraw both of them and I will look for where are they intersecting. I can even draw that here. I don't need to, but I can because I have the y-intercept of the line and I know the slope that is 100. So when I run 1, I rise 100. So this will be my line. Well, looking at this, I can see that at least I'm going to intercept my graph in 2 points, but I need to do it on the calculator, get the 2 intercepts. So I do this in the calculator and I get the intercept. That's in my case minus 3.97. I don't need more, it's 3 significant figures. And the value for this intercept is also negative, minus 0.809. Remember that I only need 3 significant figures. And that's it.